Okay, so that was like the motivation or some of the background which you need for clustering. Let's directly jump into k-means algorithm, and then later we'll see how we can use k-means algorithm for this segmentation problem. All right. Again, k-means is a very popular algorithm for clustering, and the idea is pretty simple. What we want to do is we have like some set of sample points, and we want to start with, all right, so in this data set, let's say we have 10 different categories or 10 different clusters. So that's the starting point which we need for k-means, and that's one of the limitation. Beforehand, we need to know how many different categories we have in our data set. And then the end goal is you will distribute each of that sample point to one of those categories. And that's what the k-means algorithm is going to do for you. Okay. The basic algorithm, it's a iterative algorithm, which means that you start with like some cluster centers and you perform assignment. You say that, okay, this sample belongs to this cluster. So you assign all the samples in your data set to one of those clusters. And then you keep repeating that process, which like iteratively improves that cluster assignment. And at the end, the two objectives which we discussed where we are focusing on like low similarity for intra-class samples and high similarity for intra-class samples and very low similarity for interclass samples. So we try to meet those two objectives, and then we end when we can't improve it anymore. Okay, so let's try to understand k-means using a very simple example here. So again, we have these, this is a data set we have, and these are your sample points. Okay, so each of these dot is a sample. Again, like this is projection on 2D space. You can easily generalize it to high dimensional space. So these are all the samples, and let's say we have 3 different clusters. And again, as I said, this is like a limitation of k-means. We need to know beforehand how many clusters we want. The first one is blue, the red one, and the pink one. Now what we do, we randomly initialize these centers among these points. Okay, so we know this Euclidean space. We will randomly put these centers somewhere. Okay, so that's the starting point. Now, once that is done, we try to assign each of the sample point to these centers. And that's basically based on how similar that sample is to this cluster center. And in this case, since this is Euclidean space, we can just use the distance from this point to the center. Now, if you do that, you see that all these points, which are actually closer to this blue square here, all they will be blue. Now, these 2 points were closer to the red one, so these are marked as red. And all these 4 were closer to the pink one, they are marked as pink. So that's like one step of your k-means clustering algorithm. Okay, so in that first step, what you did, you randomly initialize your centers, and then you assign every sample to these centers based on the closeness or the similarity. Now, what you do, you keep repeating this process over and over again. Okay, now in the second step, what will happen, you will take all these blue points and you will try to update the center, the cluster center. And that will basically be the mean of all these points. Okay, so you can look at like all these blue points. If you compute the mean, so the mean will be like in the x direction and the y direction, depending upon what are the x and y coordinates of these points. So you can see like the cluster center was at this location, it moved to this location. You will do the same for red cluster, and you can see it's basically at the center of these 2 points because you only have 2 points and the average is going to be at the center. Similarly, for the pink one, this will be the center based on these 4 points. Right? Now, you again reassign. What you will do, you will go through each of the sample points. You will find the distance from all the cluster centers. And again, you will do the reassignment. So basically, all these 4 points are again going to be blue. But this point over here, now it's actually closer to this red point, right? So this is going to be red. And these assignments are not going to change. Okay, because these are still closer to the pink one. So that's the second step. You again repeat the same process. You will find the center And you can see that the center for the pink is not going to change because the assignment was not updated. But the center for red will change because we have a new point now. Okay, so this will come maybe to this point, and blue might change because this was snatched away and the red took it. Okay, so it will move, and again you will do reassignment. And this point again is claimed by this one because it's closer to that center, and you keep repeating that. And unless like if the points are not changing, the centers are not changing, you say that okay, we are done now. And at the end you can see that you have 3 different clusters: the blue one, the red one, the pink one. And you can say like all these points belong to one category, which is blue. This belongs to red category. This belongs to pink category. And this was completely unsupervised. Okay. Now, so that was like the simple algorithm. As I said, it's iterative. And we have to like perform those 2 steps like in each iteration, which is kind of readjusting the cluster center and then again performing the reassignment. Okay, so for that, like again, we need a distance measure. In this case, we can just use the distance between those 2 points because it's Euclidean space. But you can imagine like if you are working in terms of features, which will be like high dimensional, for example, 5.2 dimensional or something. But again, in that case, you can compute the Euclidean distance between those 2 points, right? So that will still be valid. Okay, so the first question is what distance measure. Most of the times you will use Euclidean distance because you are working in terms of features. So for spatial data, that's actually that works pretty well. The another interesting question is, so the demo we discussed, we started like the points initially. Initially, we started it randomly, right? We just choose like any points. And then you can imagine this kind of algorithm is not deterministic, because what will happen is the initialization step is random, which means that if you run this algorithm multiple times, you might end up with different results, and that actually happens a lot. Okay, so different results will be different. So there are like different ways to address that, and one way is you can actually choose like some of these points as the initial point instead of just randomly picking it. Okay, so that's one solution, but again, that still makes it like doesn't makes it deterministic, because again you're choosing those points randomly. But the other way you can do is maybe you can take like some kind of averaging of multiple points together, right? So there are different ways to resolve this, but still like there is some kind of stochasticity there, which makes it like non-deterministic.